Myself Suresh Kumar Pandey from Christ the King Inter College, Tundla. Here is a physics video for class 7th, chapter Physical Quantity and Measurement. In this video, I will discuss its first unit, area and its measurement. Before starting this unit, I will give you a brief idea about physical quantity. Actually, physical quantity is the combination of magnitude and a unit. Examples: length, mass, time, etc. Suppose I say 100 meter race. What is 100 meter? 100 meter is the length, which is a physical quantity. If I say 5 kg sugar, what is 5 kg? It is mass, which is a physical quantity. If I say your physics exam is of 2 hours, what is 2 hours? 2 hours is time, which is a physical quantity. Now please see here, 100 meter has two parts. 100 is magnitude and meter is unit. In the same way, 5 kg, 5 is the magnitude and kg is the unit. 2 hour, 2 is the magnitude and r is the unit. Combination of magnitude and unit. Suppose if we don't write unit, then physical quantity is not possible because both are needed. Is that clear? Now the next point is area. What is area? Actually, area is the amount of surface occupied by an object. Also, we can say surface occupied by two-dimensional figures is called area. What is two dimension? I will show you with some figures. Now see, this is a rectangle and here this is cuboid. Now see, in rectangle what we measure? Length and breadth. But in cuboid we measure length, breadth and height also. Since we measure length and breadth only in rectangle, so it is called two-dimensional. Whereas in cuboid, height is also measured along with length and breadth. So this is three-dimensional. Some examples of two-dimensional figures are square, rectangle, triangle and circle. Now unit of area. SI unit of area is meter square. What is meter square? 1 meter square is the area of a square whose each side is 1 meter. Now next point is multiples and submultiples. I'll explain you multiples and submultiples with the help of some pictures. Please see. Suppose this is SI unit and this is multiple and this is submultiple. With these pictures it is very clear that multiples are bigger than SI unit. Is that clear? And submultiples are smaller than SI unit. Now the question arises, what is the need of multiples and submultiples? Actually, sometimes we have to measure big areas and sometimes we have to measure very small areas. That time SI unit is inconvenient. The multiples are used for measuring bigger areas like area of big plot of land, area of city, area of district, area of country. Here are some multiples. Please see here. Multiples are acre, hectare, kilometer square. Is that clear? 1 acre equals to 10 meter into 10 meter equals to 100 meter square. 1 hectare equals to 100 acre equals to 100 meter into 100 meter equals to 10,000 meter square. You can also write in the power of 10 power 4 meter square. Actually, when we write in the power of 10, we count the zeros 1, 2, 3, 4 and we write 10 power 4. Now 1 kilometer square equals to 1 kilometer into 1 kilometer. 1 kilometer equals to how much meter? 1000 meter into 1000 meter. So this becomes 1, 2, 3, 4, 5, 6 meter square. We can write in the power of 10 power 6 meter square. Now next point is sum multiples. Actually, sum multiples are used for measuring is area of small objects like your physics book, geometry box. Here are some sum multiples: millimeter square, centimeter square, decimeter square. These are some multiples. 1 millimeter square equals to 1 upon 1000 meter into 1 upon 1000 meter. Here I would like to make it clear that whenever we go from a smaller unit to bigger unit, we always divide. Millimeter is a smaller unit, meter is bigger unit. So when we go from millimeter to meter, we divide by 1000. So here millimeter square, so we'll write 1 upon 1000 meter and 1 upon 1000 meter, which will be equal to 1 upon 10 power 6 meter square. Is that clear? Now it becomes 10 power minus 6 meter square. Now 1 centimeter square equals to 1 upon 100 meter into 1 upon 100 meter, which is equal to 1 upon 10,000. This implies 1 upon 10 power 4, which is equals to 10 power minus 4 meter square. 1 decimeter square equals to 1 upon 10 meter into 1 upon 10 meter, which is equals to 1 upon 100 meter square equals to 1 upon 10 power 2. This implies 10 power minus 2 meter square. Now the next point is measurement of area. Area of regular surface can be calculated by a specific formula like area of a square equals to side square. Area of rectangle equals to L into B. Area of triangle 1 by 2 base into height, also we can say altitude, equals to pi r square. Area of irregular surfaces cannot be calculated by using formula because these surfaces have no proper dimensions. So, area of irregular flat surfaces like people leaf, banana leaf are determined by centimeter graph paper. In centimeter graph paper, each square is with side 1 centimeter each. Now, how we find the area of this irregular shape? Suppose we are finding the area of people leaf. So what we do, we place the people leaf on the centimeter graph paper. Then we draw the outline of the leaf with the help of pencil. Now we count the complete squares and mark incomplete squares within the outline, within the boundary. Now see how we find the area of leaf. Number of complete square plus number of incomplete square divided by 2. I just take an example, like suppose number of complete squares are 24 and number of incomplete squares are 26. So what we will do? We will divide incomplete squares by 2. So this becomes 24 plus 13 equals to 37 centimeter square. So this way we can find the area of irregular surfaces. Sometimes we have to use millimeter graph paper also for very small objects. For finding area of rose leaf, what we will do, we will use millimeter graph paper. In millimeter graph paper, each square is with side 1 millimeter each. So this way we can find the area of irregular surfaces. Thank you.